We usually think about walking purely as a way to burn calories. You log your miles on a treadmill, check your heart rate, and assume you've checked the box for a cardiovascular exercise. But that view overlooks the actual role of locomotion. Physical movement is a sophisticated environmental input system, functioning as a primary coordinator for the entire endocrine network. Now, look at how most of us spend our days. We sit inside sprawling, artificially lit workspaces, entirely sealed off behind filtered glass. This chronic separation from natural daylight breaks our biological clockwork. Without the precise synchronization of outdoor light and physical movement, the signals that modulate metabolic alertness become erratic, leaving your hormone cycles out of step with the time of day. Deep inside your brain sits a tiny cluster of neurons called the suprachiasmatic nucleus, or SCN. This is your master timer. From the moment you wake up, the SCN actively searches for precise environmental light data. It uses those light signals to set the schedule for almost every daily metabolic function in your body. Timing your gait to the sun's position allows you to manually recalibrate this master clock, aligning your internal chemistry with the external environment. The first phase of this chronobiological blueprint starts early, right at the intersection of low-angle morning sunlight and your initial daily movement. When you step outside in the first hour of waking, photons hit your retina and send a direct signal to the SCN. This triggers a mandatory surge of cortisol, which your body needs to clear out sleepiness and kickstart your alertness. But there is a major catch. If you try to get this early sunlight through your car windshield during a commute, it fails. Modern glass filters out the specific wavelengths of light necessary to activate that crucial hormonal response. You have to be outside, moving forward under the open sky. As you walk, visual images pass by your eyes. This creates what neuroscientists call optic flow, the continuous visual processing of forward movement. Generating this optic flow yourself directly quiets the amygdala, the brain's fear and anxiety center. It drastically lowers your baseline anxiety for the rest of the day and prevents erratic, unhealthy cortisol spikes. This morning sequence functions as a neurological intervention, stabilizing the body's stress response before the workday begins. By the time the sun reaches its highest angle at midday, your biological needs shift. The master SCN clock in your brain hands over the heavy lifting to local timekeepers called peripheral clocks. These are specialized timekeeping mechanisms located right inside your skeletal muscle tissue. This chart shows the percentage improvement in insulin sensitivity for two different groups of people, one exercising in the morning and the other in the afternoon. The contrast in the data is massive. The morning movement group yielded only a 3% improvement in insulin sensitivity. The afternoon group, however, saw a 34% surge in how effectively their bodies processed glucose. Taking a brief, brisk walk in the afternoon perfectly aligns those peripheral muscle clocks. It actively pulls sugar out of your blood, stabilizing your glucose levels and preventing that heavy, sluggish afternoon energy crash. Afternoon locomotion serves as an essential metabolic anchor. It reinforces your daily rhythm and starts building up the biological sleep pressure you will need later that night. As the day ends, taking a stroll right as the sun sets triggers an entirely different set of biological responses. The specific low-angle amber light of dusk hits your eyes and sends a signal to your brain's pineal gland. This instructs it to begin converting daytime serotonin into melatonin, your primary sleep hormone. But the benefits aren't just hormonal. Viewing a vast, colorful sky triggers something researchers call the awe effect, a distinct neurological response to immense natural phenomena. Experiencing this sense of awe physically alters your body. Studies show it directly reduces systemic inflammation by lowering the levels of pro-inflammatory cytokines circulating in your blood. While the soft reds and golds of dusk trigger your parasympathetic nervous system to relax, staring at artificial blue light from screens does the exact opposite, tricking your system into launching disruptive cortisol spikes right before bed. The twilight stroll signals the system to begin winding down, protecting your endocrine balance while clearing residual adenosine to facilitate a smoother transition into sleep. Keeping these systems running smoothly year-round requires what we call the seasonal calibration strategy. You have to adjust your outdoor time to match the shifting photoperiods of the seasons. For instance, To match the extended daylight of the upcoming 2026 summer solstice, your timing will need to stretch alongside the sun. Depending on where you live, you can use local light intensity metrics to satisfy your body's geographical light hunger, getting the precise photon exposure you need in the early mornings or late evenings to avoid heat stress during extreme weather. This brings us to the finalized 3-walk daily framework: a morning walk for optic flow, an afternoon walk for insulin sensitivity, an evening walk for melatonin production. This is the evolutionary remedy to modern metabolic dysfunction. Try implementing this framework for the next 30 days. By simply aligning your footsteps with the sun, you can manually reset your biological clocks, reclaim your cognitive clarity, and restore your metabolic efficiency.